So we have this problem B over here. Basically, as I've said, from problem A, this is the same problems where we actually develop and discuss the how do we solve for the free body diagrams. Okay, now there are just some excuse me. There are just some side note that I would just like to emphasize over here and review first. I already mentioned this on problem A, but I think this needs further emphasis. So from our previous discussion, we were used to sketching our force on our coordinate axis, and let's say force F. Now, force F is at angle theta, as you can see over there. Now, the question that we would like to deal with is how do we get for the x component of that force and the y component of that force? Now, if you have understood our previous discussion, that would be very easy for you to answer, and that should be clear for you to answer. That whenever you deal with the x component of the force, recall our discussion on resultant vectors, you just take the cosine of the angle theta multiplied by the force F. So whenever you try to solve for the x component of force F, that is just F cosine of theta. Whenever you try to solve for the y component of force F or F sub y, that is just F the sine of theta. And the very important side note there is that that only works, or that equation holds or relation holds, whenever your theta is measured in SPA. Okay, I'm hoping that is clear because we are going to use this in our summation of the forces. Now, I know there is this statement over here, so let me just read it for you. When theta is in SPA, you disregard the direction of the forces on your FBD. And I know that sounds terrifying, but I will explain what it meant when we try to deal with our summation of forces later. Okay? So let's try to do the summation of forces of body 1. So for body 1, um, again and again, I'm hoping you understood now why we have this. First, the sum of the forces, we indicate that we are looking at x, so we have subscript x is equal to mass multiplied by the acceleration also along x. Now again, the mass that we are talking in this case, since this is for body 1, is for the mass of this body 1 where we actually created or base our free body diagram. So that should be the mass of the cart, and the acceleration that you are seeing here will be the acceleration of the cart also. Okay? So what happens now? So simply, once we have the correct, assuming we have the correct free body diagram, we can already solve for the summation of the forces. Now, I highlighted already the forces which are on the x or along the x component or x-axis. So firstly, you have your T1. So I'm going to write T1, and T1 over there has a positive sign because basically the forces on T1, this one over here, is situated towards the positive x-axis. Now, take special note of this one. I will write the other force that exists or has a component along the x is your W sub x. Now, normally you should write it minus W sub x. But I will not do it because of this. When theta will be measured in SPA, we will try to use SPA today. Disregard the direction on the FBD. So I will just write plus. So I will just write plus Wx is equal to, what are the other forces? There are no other forces along x already. M acceleration along x. Okay, so I'm hoping that is clear. Now, T1, we don't have a problem with T1, but we have something to do with Wx. So how do we get this Wx over here? So we get that Wx by remembering this one. This over here kana siya na if you try to take the component that is just cosine for x, sine for y, assuming that your theta will be an SPA. Now, if I take that the thing that I just said, I will write plus W, and since this is x component, cosine of the angle theta, and you have to take note that should be an SPA is equal to m. I should denote it by m sub c. Dapat m sub c ni siya, class. Why m sub c? Because we are talking about the mass of this cart over here. We actually have two masses manggod. Kini siya kay mass po di sa bucket. Tapos ni siya mass. So m sub b. Ni siya m sub c. Just for distinction. Okay, para di ta mawala. Okay, so going back here, a sub x. Now, what will happen to theta? Now, theta, take note, should be measured in SPA. So you should start in the positive x, going towards this direction. Now, clearly, that is, so from this point up until this point, you already have 180 degrees plus, kini sila, kini nga area diri that is, in the entirety of that is 90 degrees, but since it na kay 15 degrees diri so you subtract 15 degrees, so 90 minus 15, so you have 180 plus pila man ni siya, this is 75 degrees, right? And that will give you 220, 220, is it 220? So it's 255, sorry, it's 255 degrees. Is it correct? 255. So we have 180 plus 90 should be 270. It means at this point 270 degrees. So if you have 255, you add 15. Okay, that's right, 255 degrees. So that means to say that your theta over here will be 255. So you have T1 plus W cosine of 255 degrees is equal to MCAX. So why did I disregard the direction on the FBD when I used SPA? So let's try to discuss that one. Nganong, sir, normally you should have negative WX. Now, nganong imuha man plus WX lang, sir. So that is from the note here when you are in SPA, when theta is measured in SPA, you disregard the direction. Why? Basically, when you try to input this cosine 225 sa imong calculator, class, the calculator automatically will give you the sign, either positive or negative. So clearly in this case, this is negative value. So try it in your calculator. That will give you a negative value. So if I input a negative value over here and I take, instead of writing plus, I write here negative, the net effect of the two sign is positive, which is not the case. Since basically your WX is found on the negative x-axis, when you do that, that will tell you that it's positive, which is again not the case. So that's why whenever you deal with SPA, angle nimo, you're using SPA, always try to disregard the direction of the forces on the FBD. Katong na ay mga component nga forsa, in this case, the W sub X. For reason that whenever you plug in the value of that either cosine or sine on your calculator in SPA, the calculator automatically will carry the sign, either positive or negative. So that is why we always just take the plus. We always take the sum. So instead of writing this one, I'm hoping this does not have led to any confusion. Whenever you write W sub X and then you're planning to use SPA, you just use plus W sub X and not negative W sub X. Okay, I am hoping that is clear to you. Now, another thing from problem A, you probably are thinking that, okay, I will cancel A sub X. Now, in this case, class, if you try to analyze a problem, this will actually move towards here in this direction. moves towards that, and this bucket also moves downward over there. So there will be an acceleration on your cart. Therefore, you could not x that one out. So you just write mca sub x, and this is your equation 1. Okay, so I am hoping that is clear. Now, what if, sir, I don't want to use SPA? I want to use SOHCAHTOA. So there is no problem with that. So if you want to use SOHCAHTOA, basically the same. The same lang yun ang mahitabo. So upon using SOHCAHTOA over here, what happens is that you have the sum of the forces in X. The same regular siya class na process will be M, mass of the cart, acceleration of the cart along X. So what are the forces? The same. Basically, you have T1, but take note of this. Since you are no longer using SPA, you want to use the 15 degrees because you don't want to use SPA in that case. You want to use this angle. You have to carry the sign. So in this case, negative WX is on the negative axis. So you will take negative W sub X. So this is like the main difference in using SPA. Because again, when you are using SPA in your theta there, you take plus WX, meaning you disregard the sign of the force on the FBD. But if you don't want to use SPA, that means you want to use the given angle, you have to take into account the sign. Okay? So, continuing on this one, this will be T1 minus, okay, WX. Now, this is your WX. So, the question again and again is, what is the relationship between your angle and WX? So, they are opposite. So, of the two trigonometric relation, the only function which has opposite is your sine, right? So, this is telling you that the sine of the angle, which is 15 degrees, is equal to the opposite, W sub x, divided by the hypotenuse, which is just the weight. Because again, hypotenuse is always 90 degrees from opposite to the 90 degrees. So this is telling you that W sub x is simply W sine of 15 degrees. So you have here W sine of 15 degrees. So it's equal to MC A sub x. So this will be your equation 1 if you are not using uh, SPA. Alright, so it's up to you what you should do, SPA or not SPA. Now take note that why we carry this negative sign over here, class, or we consider the negative sign on the FBD if we're not using SPA, because if you try to plug in your calculator sine of 15, that will give you a positive value. So positive multiplied by negative, the overall effect of the two sign will be a negative value. So negative value over here. And that is correct. Dapat negative ang value because WX is on the negative x-axis. Balikon ako diri sa pikas. Nganong i-disregard na to sa SPA, or if you are using SPA, cosine 225 gives a negative value. Negative na siya nga sign daan sa imong calculator. So when you try to multiply that with positive value, the result is negative. And that is also correct, that should be negative since WX is found on the negative x-axis. Okay, so just to avoid confusion, I am summing up. Whenever you use theta as a standard position angle measurement, you disregard the direction on the FVD. If you're not using SPA, you have to take into account the sign on the FBD. Okay? So I am hoping that is clear, and you will have exercises for problem C and D. And I will post the solution later for you to try it on your own. So yeah, that's your equation 1. Let's go back here. And for the rest, magkuan na din ko class SPA na din akong gamiton for the rest. So for the first free body diagram, body 1, we are done with the X. So we are still to write the sum of the forces along Y. And that is equal to M, mass of the cart, acceleration along Y. Alright. So when we do this, what will happen is we simply look at the free body diagram. So what are the forces that you can see on the free body diagram along the y-axis? So along the y-axis, you have the normal force and it's moving up. So I will take that to be positive. And on my y-axis, or there is a component along the y, which is a w sub y. And since I will be using SPA, I will just take plus w sub y is equal to mc a sub y. Okay? Now, ngano ganing akong gigamit lang ang plus w sub y even though it is on the negative y-axis because I will be using SPA. So when I do that, I will have normal force plus w sine of 225 degrees. Okay, I will just write the detail. Sine of theta is equal to mc a sub y. Now, the normal force N plus W sine of 225 is equal to mc a sub y. So, this is your equation 2. Anyway, yeah, that's your equation 2. However, we can do something about it. Take note that in your free body diagram class, your body is moving towards this direction. So it's moving with a velocity towards this direction. And take note, if you remember this direction over here is actually our x na direction, right? Kadumdum ani katong gi-rotate na to, the one we rotated the axis. So this is our x direction or the x axis. So clearly our acceleration is only on the x axis. So we don't have any acceleration along the y axis. Kaya wala man siya galihok along the y. So to simplify this one, your a sub y in this case will just be 0, and that will lead you with the equation n plus w sine of 2 to 5 degrees, that is equal to 0. So that's your equation 2. Now, if you don't want to use SPA, you can continue here on this side. You will get the same result regardless, okay? So that's it for your equation 2. And for your for your body 2, it's very easy. So clearly there are no forces along the x-axis here. So that will tell you that the sum of the forces along the x is just equal to 0 because there is nothing there. So maybe you call that equation 3 if you want. So equation 3, but you don't have to write that. It's fine in the exam if you don't write what's the summation of forces on that, as long as you are sure it is 0. Now, the sum of the forces along y-axis for body 2 is equal to m a sub y. But you have to note again that m should have a subscript of b, meaning that is the mass of the bucket, just to distinguish from m sub c, which is the mass of the cart. So what are the forces existing on on body 2 along the y? First, we have tension 1, which is directed up. So we have T1, and the weight, which is directed downward. So minus the weight is equal to mb a sub y. Okay, I am hoping that you are seeing that. Now, I'm just going to break down your weight. So I have T1 minus mass of the bucket multiplied by the acceleration due to gravity is equal to mb acceleration along y. So this is now your equation 3. All right. So I am hoping you understood the summation of the forces. How do we get the equations for the summation of the forces? And for the second problem, for problem C, so you may try it on your own. and then I will post the solution later for you to check.